Hello everyone, and thank you for joining today's webinar on GitHub Copilot usage-based way. Before we begin, think about how much GitHub Copilot has evolved, say from simple code suggestions to debugging, code reviews, documentations, and even agentic workflows. As AI usage grows, understanding how it's measured, governed, and optimized becomes increasingly important. And that's exactly what we cover today. I'm Hemavati, technical trainer from Canarys Automation. So let's dive in and explore how organizations scale GitHub Copilot adoption confidently, responsibly, and effectively. Before we move into technical discussion, let me quickly introduce Canarys. Canarys is a global IT solutions and consulting organization with decades of experience, helping enterprises with, say, digital transformation, DevOps modernization, GitHub adoption, AI enablement, cloud engineering, and enterprise engineering transformation. We work extensively with enterprise engineering organizations, helping them scale DevOps practices and improve developer productivity. Canarys is a Microsoft Solutions partner and GitHub verified partner with over 20 years of experience helping organizations accelerate their digital transformation journey. We have a strong global presence across USA, India, and APAC, supporting customers across industries such as BFSI, retail, manufacturing, pharma, and healthcare. Our expertise spans DevOps, GitHub, Azure, application modernization, and AI powered engineering solutions. We are proud to have a team of 600 plus professionals, including GitHub certified and DevOps specialists, helping enterprises adopt modern engineering practices at scale. I want to quickly highlight something important about the GitHub ecosystem and our journey with customers. We are proud to be recognized as GitHub Channel Partner of the year 2024 and GitHub Growth Services Partner of the year 2025. Our solution offerings span across, say, DevOps implementation, security integrations, workflow automation, migrations, AI enablement, workshops, and enterprise modernizations. At the center of all of these initiatives is one common goal: improving engineering productivity. And AI is now becoming a foundational layer in achieving that productivity. At Canarys, we strongly believe in giving back to the developer community. We have built and published developer-focused tools and extensions such as Code Pointer, Git Blame Hover, and Laser Pointer for Visual Studio to improve developer productivity and everyday workflows. And with this developer productivity evolving rapidly through AI, let's look at how GitHub Copilot is used and its usage-based billing. Let us quickly recall what is GitHub Copilot. Most of us know GitHub Copilot as an AI autocomplete tool, but Copilot today has evolved far beyond that. It now supports code generation, debugging, documentation, architecture discussions, refactoring, test generations, agentic workflows, code reviews, and automation. Copilot is evolving from a coding assistant into an AI engineering collaborator. And as AI capabilities expand, AI consumption patterns also evolve, which naturally brings us to billing. Now, let's come to the core topic of today's webinar. GitHub Copilot billing is evolving. Effective June 1st, 2026, premium requests are being replaced with GitHub AI credits. This is a major shift. We are moving from request-based billing to actual AI consumption billing. And this aligns much more closely with how AI providers themselves price compute usage today. Before we understand what's changing, let's quickly look at how GitHub Copilot billing worked earlier. Each user received a fixed monthly allowance of premium request units, which resets every month. Different AI models consumed PRUs at different rates, with advanced reasoning models using more units per request. And if users exhausted their PRUs, they could automatically fall back to lower cost models and continue working, while admins could control the additional usage through budget settings. Now, while these models worked well initially, as AI capabilities expanded, it became increasingly difficult to accurately reflect actual AI consumption, which led to the evolution of usage based billing. Now that we have seen how previous model worked, let's look at what's changing. The biggest change is that PRUs are being replaced by GitHub AI credits, bringing billing closer to actual AI consumption based on tokens. A few other important updates are, say, no more automatic fallback to cheaper models once AI credits are exhausted. Usage is now managed through budget and governance controls. For teams, credits move to a shared pool model, improving utilization across the organization. And Copilot code review will also consume GitHub action minutes. One thing that's not changing is your Copilot subscription pricing. The plans remain the same while the way AI consumption is measured becomes more transparent and predictable. So the goal here isn't to charge more. It's to provide better visibility, governance, and scalability as AI usage continues to grow. So now that we know what's changing, let's understand the core building block behind this new model, GitHub AI credits. First, premium request units go away entirely. They are replaced by GitHub AI credits, which are consumed based on actual token usage. That is, input tokens, output tokens, and cache tokens, which are going to be priced accordingly to the published API rate card for each model. Billing is now deterministic and transparent. No more abstraction layers. Let's say a request to GPT 4.0 costs what its tokens cost, and a request to a lighter model costs less. Say cached tokens are billed at a reduced rate, so a repeated context within a session is going to be cheaper. So let's get into deeper. Let's look at the capabilities of UBB in detail. The first big unlock is a broader feature set. Under the old model, every request was metered the same way, which meant we were constrained in what we could offer. But with token based billing, we can now support larger context windows. That means Copilot can ingest more of your code base, more of the surrounding file context, and produce higher quality completions. You will also get access to newer, more capable models as they become available without waiting for a pricing restructure, and also looking ahead with the future agentic features, multi-step workflows. Copilot can reason across file, run tools, and iterate on solutions autonomously. The second major unlock is the pooled entitlements across users. This has been one of the most common requests from the enterprise customers. Under the previous model, each user had their own individual premium request allocation. If one power user burned through their requests while others barely touched theirs, there was no way to redistribute. Now, all AI credit entitlements pool at the enterprise level. Every licensed user draws from the same shared pool, which means your organization's total investment is utilized much more efficiently. Now, let's get into the mechanics of AI credits. So, what counts as a token? Tokens include everything in the interaction. Say the prompt you send, that's going to be your input tokens. The response you get back, those are going to be your output tokens. And any cached context that carries over from the prior turns in a session. So each of these token types has its own rate on the model rate card. So with cached tokens being the least expensive, since they are reused context rather than a new computation. Before we proceed, we need to understand the two main categories of usage. One is the included usage, another one is the additional usage. So when it comes to included usage, every Copilot license contributes a set amount of AI credits to a shared enterprise pool. All your licensed users draw from this pool. For most organizations, especially during typical development workflows, this included pool will cover a significant portion of your usage. The next one is the additional usage. So anything beyond that included pool, this is where budget controls come into picture. Additional usage budgets are set in US dollars, and the usage itself is tracked in GitHub AI credits. Now, the conversions is simple and fixed. One AI credits equals 1 cent. So, if you set a $10 additional spend, then that gives you exactly 1000 AI credits of headroom beyond the included usage. This makes it very easy to forecast and cap your additional spend. Now let's have a look into more details to understand it better. Now let's understand the three token types. First, the input tokens. These represent everything you send to the model. Say your prompt, the surrounding code context, open files, and any additional context the tool assembles on your behalf. This is typically the largest token category in a given interaction, and it scales with the size of your code base and context window. If you are working in a large monorepo or passing entire files as context, your input token count will be higher. This is one of the key levers for cost. The more context you provide, the more input tokens you consume. The second one is the output tokens. These are the AI generated responses. Say it can be the code, the chat answers, the tool use calls, and say any other content the model produces. Output tokens carry the highest per token cost because they require the most computation to generate. Short code suggestions consume far fewer output tokens than a multi-paragraph explanations or say a large code refactoring. The third one is going to be the cached tokens. This represents say the context that's reused from your previous interactions within the same session. Say when you're having a multi-turn conversation in Copilot chat, the model doesn't reprocess all the prior context from the scratch. It caches it. And cache tokens are the least expensive ones, and they also improve the response speed. The takeaway here is simple. That is, not all tokens are equal in cost. Output tokens are the most expensive ones, input tokens are in the middle, and the cached tokens are the cheapest. When you are optimizing for cost, focus on understanding which workflows generate the most output tokens and which models you are routing them to do. Now that we understand the three token types, the next logical question is what actually increases or decreases the consumption? There are multiple factors. Say first one is the model selection. Different models consume credits differently. And the second one is going to be the prompt size. The more context we send, the more tokens gets processed. And the third one is going to be the response size. Say if you ask Copilot to generate an entire architecture document instead of a short answer, naturally the consumption increases. And finally, the agentic workflows. So when it comes to agentic workflows, This is where the things become interesting. Traditional AI interaction was just a question and an answer for it. But the agentic workflows are, say, where we agents think, plan, analyze, call tools, generate, validate, and also retry. So AI is no longer just responding. It's actually executing multi-step reasoning. And that naturally consumes more computation. And when it comes to using skills or MCPs, the tools attached, all of these is where the token consumption happens. So this is exactly why GitHub needed a smarter billing model. Let's talk about billing based on model. Not all the AI models cost the same. Think about booking transportation. Say if you're traveling alone, you might book a bike taxi. But if you're moving along with your entire family, you probably will be booking a larger vehicle. Both get you to the same destination, but the cost is different because the work done is been different. The same concept applies to the AI models as well. Let's take a simple example. Say, suppose I have a simple query, say, fix the spelling mistake in the comment. So, a lightweight model can do that perfectly well, right? But now imagine that I ask Copilot to say analyze this 5,000 lines of application, identify its root cause of performance issues, suggest fixes, and also generate the test cases. So that requires a much deeper reasoning and significantly more compute power. Looking at the numbers on the side, you can see the differences. Say, for example, GPT-5 Mini costs around $0.25 per million input tokens, whereas the Cloud Opus 4.5 costs around $5 per million input tokens. That's nearly 20 times higher for the same volume of input. And when we look at the output tokens, the difference becomes even more significant. So the key takeaway is that every task doesn't need more powerful model. It depends on the task. Say, I would suggest you to choose the right model for the right task. So that's where organizations can significantly optimize, usage while still getting the best outcomes from GitHub Copilot. Now that we understand why model selection matters, let's look at what remains unchanged in the new billing model. Whenever billing changes happen, everyone get nervous. So let's clarify what is not changing. Your base Copilot pricing remains exactly the same. Copilot Business stays at $19 and Copilot Enterprise stays at $39. Also, the code completions and next edit suggestions remain included, and which means developers can continue using Copilot naturally for their day-to-day coding activities. The changes primarily affect the advanced AI workflows, larger context usage, agentic capabilities, and premium reasoning models. So this is not every keystroke cost money. Its advanced AI compute now becomes measurable and governable.
This slide is extremely important. Earlier, when PRUs exhausted, users silently fell back to cheaper models. Most organizations did not even realize it. But now there is no silent fallback. Why? Because enterprises want governance and predictability. Instead of silently degrading experience, GitHub now uses explicit budgets and controls. Another important change is that Copilot code review also consumes GitHub action minutes. The reason? Because code review is not simple autocomplete anymore. It performs repository analysis, dependency understanding, security evaluation, reasoning, and multi-step AI execution. So this is another example of Copilot evolving into an engineering platform.
So far, we understood how billing works. Now, let's move into the real enterprise discussion, that is, usage mapping and governance. Because visibility alone is not enough. if organizations don't control AI usage properly, say costs can spike, adoptions become unpredictable. So GitHub has introduced layered governance. Let's have a look into it. Let me explain the budget layers. Let me start from the bottom of the hierarchy, say with the individual user. Because that's where the AI consumption actually happens. Imagine we have 100 employees using the AI. First, we define an universal user budget. Let's say every user gets a default additional usage limit of say $50 per month once the included AI credit pool has been exhausted. Now, not every user has the same needs. For example, Sarah on the engineering team uses AI extensively for coding. So instead of the default $50 limit, we can assign her an individual user budget of say $200 per month. That individual budget overrides the universal default, giving us flexibility to support say power users while still maintaining the overall control. Now let's move up one level to the organization. So organization represents say departments, business units or the cost centers. Suppose we allocate budgets, say for engineering team gets $5,000, marketing team gets say $2,000 and support team gets $1,000. These organization budgets act as team level spending controls. Even if the individual users still have budgets available, the team cannot exceed its allocated organization budget. For example, Sarah may still have $100 left in a personal budget, but if the engineering has already consumed its full 5,000 allocation, additional usage stops. Finally, at the top of the hierarchy is the enterprise budget. Let's say leadership decides that beyond the included AI credits, right, the company is willing to spend a maximum of say $10,000 per month. This becomes the global spending ceiling for the entire organization. If the engineering has a budget remaining, or say marketing has budget remaining, and the users still have individual limits available, once the total company spending reaches $10,000, no additional usage is allowed. So, in practice, every request is governed by three layers. Does the user still have budget available? Does their organization or the cost center still have budgets available? As the enterprise-wide spending limit being reached, all three conditions must be true for the usage to continue. This layered approach delivers the balance that enterprise need. So users get the freedom to innovate, managers get the visibility into team consumption, finance team gets predictable spending details. So leadership gets the confidence that costs remain within the approved limits. And that's what makes usage-based billing truly enterprise ready. Granular controls at the user level, accountability at the organization level, and governance at the enterprise level. One of the smartest improvements GitHub introduced is the pooled entitlements. Earlier, every user had a separate unused capacity. So imagine say one developer used only 10%, another exhausted everything. So unused capacity got wasted. But now the enterprise has one shared AI credit pool. So think of it like everyone had separate water bottles previously, but now the organization has one shared water tank. So this dramatically improves efficiency. And only after the shared pool gets exhausted, additional spend begins. Again, the additional spend is managed with the enterprise AI credit budget. At the top of the governance sits the enterprise budget. So this controls whether additional spend is allowed or not. And if so, how much maximum spend can happen. This becomes your AI spending ceiling. Say, for example, your organization may say, we are comfortable spending up to, say, 10,000 additional AI credits per month. So, this creates predictability. And this is exactly how, say, the cloud governance evolved years ago. So, AI governance is now following the same maturity journey.
Let's go one layer deeper. Larger organizations don't operate as one single engineering team. They would have different departments, consume differently, and innovate differently, also prioritize differently. So GitHub allows cost center budgeting, meaning you can allocate AI spend across departments, business units, or engineering groups. This becomes extremely valuable for, say, chargeback models, internal reporting, and optimization analysis. Finance teams especially would love this visibility. Now comes the fairness control. Because in every organization, some users become powerful users. One engineer may casually use Copilot, whereas another engineer may run large debugging sessions, multi agent workflows, or heavy migrations without controls. So, a few users can consume a huge percentage of enterprise credits. So, GitHub has introduced universal budgets and individual budgets that apply accordingly. When I say universal budget, it applies to everyone, and individual budgets allow overrides for, say, architects, platform engineers, migration teams, or heavy AI workflows. This balances freedom with governance. Now let's look into the billing and licensing. If you notice in billing and licensing, let's go into the usage, AI usage. Within the AI usage, you will be able to see the included credits as well as the additional credits. So when it comes to included credits, you can notice we have 16,000 AI credits, out of which we have consumed 1,071 credits as of now. And this is going to be billed for 28 days. And apart from that, if you notice, we also have additional AI usage, which is currently not enabled, but can be enabled. And if you notice, if enabled, your enterprise will be billed for additional AI credits only after your included usage is being exhausted. And apart from that, if you notice, we can also see a graph and then the usage breakdown. And in usage breakdown, you see the usage based on models. So I can just show you it has been grouped by models, users, right under the pointer. And you can notice in users, so you can see the three users, their included credits, the AI credit, additional credits, their total additional usage cost, and the gross amount. And you can also see the cost center. In both of the cases, you would be able to see the usage with respect to models. So here if you notice, there are two cost centers, and selecting a cost center, you can again see with respect to the models used, the included credits and the additional credits, the gross amount and the total additional usage that has been done. We have now understood how billing works and how governance layer work. But enterprises also need operational visibility because what gets measured gets optimized. This session focuses on monitoring, alerts, visibility, and usage tracking. And honestly, this is where platform teams become extremely important. Before the usage based billing rolled out, existing PRU budgets continued functioning normally. This is important because organizations need transition stability. GitHub designed the migrations carefully so that enterprises don't suddenly experience disruptions. This idea is a gradual evolution, not a overnight chaos.
Here is what happens from June 1st with usage based billing. The most important thing is that your budgets are automatically transitioned into AI credits. So there is no manual migration required from your side. The systems handle the conversions so that you're protected from the day one itself. A few things, change in your billing experience would be, say, first thing would be your included usage now reflects the pooled entitlements, right? It's not the individual person, but it's going to be the pooled entitlement. So of your say Copilot business and the Copilot enterprise licenses. So instead of seeing a per seat allocation, you will see a consolidated pool, which is actually simpler to manage. Second, the billing UI is updated to show the AI credits as a measurement of unit measurement with say filters available say by model and by users so that you can drill into exactly where usage is going. So we will have a look into it in the next slide. And one more thing to note is that no user level budgets are set by default on the day one, right? So this is important. This is made intentional because so that it gives you the flexibility to review your initial usage, right? The usage patterns before deciding where to place an individual guardrail. So you're not locked into anything and you can add user level budgets whenever you're ready. But please keep an eye, on the power users. One recommendation GitHub strongly encourages is to configure user level budgets earlier. Why? Because governance works best proactively, not reactively. If organization waits until the costs spike, right, optimization becomes painful. So, a better approach is to start with a lightweight guardrail, observe the behavior, and then optimize it gradually. Now, let's have a look into the step one of the three user level budgets. So, when you're going to get started, right, when you're viewing per user usage in the billing interface, the system prompts you to consider the settings user level budget. This is a proactive nudge. The system is essentially saying that, hey, you are looking into individual usage data. So would you like to set some guardrails here? So user level budgets track both included usage as well as the additional paid usage. So this is important. It's not just capping overage. It's also giving you visibility in total consumption per person. So the primary use case is like preventing a single user from depleting your entire shared entitlement pool, right? Or from generating surprise cost overruns. So think of it that parent distribution like 80 to 20 rule we discussed. So if you have a few heavy users consuming disproportionately, user level budgets are the one best part, right? From where you can have a track of. So the step two of user level budget flow would be setting up an universal budget, I can say. When I say universal budget, it is when you decide to enable user level budget, the system prompts you to start with, say, universal budget, the same amount for every user. This is the fastest way to get the guardrails set in place, right? Without analyzing each individual's usage. Pick a reasonable number based on your total pool and user count and apply it universally. And you can you have instantly got a safety net across the entire organization. So it's a fair baseline that treats everyone equally. Then set a universal budget, let it run for billing cycle, and then use the actual usage data, right, to make informed adjustments. So some users will never come close to their limit and some will bump up against it. So that data tells you exactly where to make individual exceptions. Imagine being an enterprise admin managing thousands of developers. You need visibility into, say, heavy users, low users, blocked users. That's what we are going to see here. So once your budgets are in place, the admin view gives you a clear breakdown of where every user stands. The billing UI groups user into, say, three categories. One, users who are at their limit. Two, the users who are approaching their limit. And the users under 75% usage. This categorization let you spot potential issues at glance without having, to scan through individual numbers. So from the same dashboard, you can also view usage per user and also update individual budgets as needed. So if you see a developer who's consistently hitting their limit and impacting the productivity, then you can bump their budget up right there. Conversely, if you notice user who are like nowhere nearing the limits, that tells you your universal budget might be set higher than necessary, right? You could tighten it and also reallocate that headroom to the users who actually need it. So this is where the iterative approach really pays off. After one or two billing cycles, you will have a clear picture of your organization's usage distribution and you can fine tune budgets with confidence.
During the billing cycle, GitHub first consumes included enterprise entitlements. Only after those shared credits exhaust, additional spend begins. This is extremely important conceptually because many organizations panic unnecessarily thinking every AI interaction immediately costs extra. That's not true. The shared pool gets utilized first. Only then we move on to the additional credits.
Now, let's discuss the operational safeguard layer. So, GitHub provides an alert at say 75%, 90%, and 100%. So, this is critical because organizations should never discover or overspending at the end of the month. So, instead, they get proactive visibility. And once the limit is reached, the usage stops until the budgets increase or the billing cycle resets. So this creates a strong enterprise governance.
Let us now look into the budgets and alerts from the billing and licensing section. You can see we can click on new budget and set the new budget. And when setting up the new budget, you can notice we have the budget types within which we can select the AI credit budgets and then the product level budgets in which we have actions, copilot. Apart from that, SKU level budgets. And in SKU level budgets, again, we have it based on product and SKU where in product you select various products or the SKUs when it comes to say Linux actions and cache action storage. Now, our main focus is going to be on AI credits budget. So now let's have a look into Copilot here. When going to AI credits budget, selecting it and click on next configure budget, that is where you have the budget scope that can be selected. When selecting the budget scope, we have enterprise level, organization level, cost center level, and user level. And when it comes to enterprise level, just in case you have the cost center usage, that can be actually excluded by selecting this checkbox. And apart from that, if you notice, we have the user level that can be set. So when you're going to select and set the user level, you have two options. One is selecting only the users, which means the universal budget is going to be selected that applies to everyone. So for example, if we are trying to set $20 per user, then at the universal level, so each user is being allocated with say $20. So now we are trying to create the budget over here. But let's say you have some power users and you would also want to set some additional budget to those power users. So in that case, what you need to do is you are supposed to select the users. So for example, here you can see we can select Aditya Meda or say Akshay or Aditya. Anyone can be selected and we can try to assign an amount to that particular user. So for example, here let us try to set some amount for this particular user, say $35. So now what happens with respect to Abhilash, we have tried to assign an additional $35 apart from the included usage that is from the that was set from the universal level budget. So this way you have a complete control of how exactly you would want to set the AI credits to the users.
Challenge that organizations quickly discover is that considering to set the budget. AI usage is not evenly distributed. Some teams barely use AI, others become extremely AI driven. For example, migration teams or debugging teams, right, often consume significantly more. So organizations must understand the usage patterns, before aggressively optimizing it. So, and this is where analytics become valuable. So, knowing the power users, high use organizations, or say high use cost centers, and the models preferred, right? All these factors inform how you mix and match the budget tools we have discussed so far. So, do you use universal level budget to ensure fair usage across the board? Or do you give certain power users the higher budget? So, it's all up to your considerations. Let's understand the budget scenario planning. These examples may initially feel mathematical, but they are extremely practical because they stimulate real enterprise behavior. And once you understand shared pools, user budgets, and cost center limits, the governance model becomes very easy. So, this is essentially important for you to understand so that you can do plan your scenarios, budgets accordingly. Now, let's get into the example. The first one is going to be the fair use scenario. When it comes to the fair use scenario, this is our baseline. Imagine you have 10 Copilot business seats. This gives you an enterprise included AI credit pool of say $190 per month. And in that $190, uh, 10 users times $19 used. On the top of that, you have set an enterprise level AI credit budget of say $310 per month for additional usage. And then you have tried to set a user level budget of say $50 per user. Then here is what happens. So all the 10 users consume the same $190 shared in pool. When that pool is exhausted, then the users start consuming that $310 enterprise level budget. That is your additional spend. So each user can spend up to $50. So total thanks to the universal level user level budget. So once they hit the cap, then they are blocked individually. So if the user consumes their full $50 usage, right, the total enterprise usage is going to be $500. So 190 is actually from the pool and 310 is going to be the additional spend that was done. Now let's understand the cost center scenario. It's going to be the same setup as before. We have 10 Copilot business seats, $190 shared pool, right? And the $310 enterprise budget that is being set. So $50 universal level budget. But now 5 of those 10 users belong to a cost center A, which has its own cost center budget of say $160 per month. Now, in the first cost center scenario, we assumed equal consumption. Everyone uses the pool at the same rate. So each of the 5 users in cost center A consume $19 from the $190 shared pool, right? And the other 5 users outside the cost center also consume that $19 each. Now the pool is exhausted evenly. Now, each user in the cost center A has $50 user level budget that is being set. So, they have already used $19 from the pool, so each has $31 remaining. Since the pool is gone, the remaining $31 per user counts as an additional spend. 5 user times $31 equals $155 of additional spend attributable to the cost center A. So here is the key inside that. The cost center budget is $160, but the actual additional spend was only $155. So in this equal consumption scenario, the cost center budget is never reached. The user hits their individual $50 user level budget caps first. The user level budget is binding constraint, not the cost constraint budget. But what happens when the pool isn't consumed equally? That's where things get interesting. And that's exactly what next scenario is. Look into cost center scenario blocking. Same setup, right? Having 10 seats, $190 pool, $310 enterprise budget, $50 user level budget set, and the cost center A with 5 users and $160 being set at the cost center budget. The only thing that changes is the usage pattern now. So this time, 5 users say outside the cost center A is consuming the shared pool faster. maybe because of the faster Copilot agentic use cases. Whatever the reason is, so let's say they have consumed $25 from the pool, while the five cost center A users have consumed only $13. So the $190 pool is still fully exhausted, right? Uh, and now what happens is each user from the cost center A has $50 user level budget and only use $13. So now each one has $37 remaining from the budget. However, when you consider $37 for five users, it's going to be $185 of potential additional spend. But what happens here? The cost center's budget set is $160, and because of which, even though the individual users still have the budget remaining in their user level budget, the cost center budgets become like kind of a binding constraint, and the users are going to be blocked. And here the constraint is not the user level budget, it's the cost center budget. And because of this, the way the shared pool gets consumed directly affects which budget layers triggers first. Unequal pool consumption shifts the balance between user level and the cost center level controls. Optimizing quality and tokens. So this is personally one of my favorite sections because organizations that win with AI are not the ones spending the most tokens, but they are the ones who use tokens intelligently. Many teams unknowingly use the premium reasoning models, say for simple tasks like typo fixes or comments or formatting. That's equivalent to using kind of a supercomputer to open Excel. So optimization starts with using the right model for the right task. And along with that, providing relevant context is essential. So the quality impacts, right, depending on the context that is being given to the model. So one of the biggest hidden cost factors is going to be poor prompting. Say unclear prompts create retries, larger outputs, unnecessary reasoning, and token waste. Good prompts improve, say, quality, speed, and consistency, and also cost efficiency. That's why the prompt engineering is becoming an engineering skill. So let's say be precise. Say just say fix the bug. Instead of saying fix the bug, try to specify it as issue number 45 describes a bug where XY happens, fix it. That gives a clear understanding and lesser token usage. Features like say Copilot instructions, scoped context, prompts files, and memory help standardize the AI behavior. This improves consistency. Let's say within the Copilot instructions, you clearly specify uh, the conditions that the agents are supposed to follow or the way the output is being obtained, right? So when you're trying to add these details, it improves consistency, predictability, and also optimization. And for enterprise, say standardizations becomes extremely valuable. We summarize optimization. First thing would be to reduce the unnecessary context, to use the right model, say monitor heavy usage, and also configure budgets properly and optimize the prompts and continuously review the usage trends. The goal here is not to use less AI. The goal here is to use AI intelligently.
Here are the biggest best practices that organizations should follow. Start simple. Monitor continuously. Make sure to use the right model for the right task. Educate developers and create governance early. Try to go ahead and use, say, research, plan, and implement method and provide deterministic guardrails. Optimize iteratively. The organizations succeeding with AI today are the ones combining technology, governance, and enablement together. A very practical rollout approach is Start with visibility first, then enterprise limits, then cost center allocation. Then comes the fine-grained optimization. This phased adoption avoids overwhelming teams.
Usage-based billing is not just a pricing update. First, review your enterprise usage pattern. You should be looking at your current Copilot usage data to understand where you fall on the distribution curve. Second, try to align on budget controls and usage expectation. This means answering some specific questions within your organization. And then the third one is to consider how you want to advise your organization on usage. Partner with your development teams to optimize usage pattern. This goes beyond just setting budgets. It's about helping your developers get the most value per token, which naturally reduces costs while improving the productivity. Now the question becomes, how do organizations actually operationalize this successfully? That's where enablement and workshops become important. Now let's talk about what comes next, the concrete steps you should take to prepare for the for and optimize under usage based billing. We help organizations through enablement path. Say it can be a workshop. It's a one-day workshop where platform teams, admins, and developers can get involved into the hands-on developer training with say prompt engineering, token optimization, and real-world coding scenarios. And there is also another 2 week enablement sessions. So, wherein you try to have a deep dive baseline assessment, understanding more about setting up the Copilot instructions, and also having model sizing, governance strategies, and adoption accelerations. So, you can decide whether you would want to go ahead with a 1 day workshop or a 2 week enablement course. So, if your organization is starting its usage based billing journey or planning governance and optimization strategies, we would be happy to support your teams. So, you can contact us on this email devops@ecanarys.com. I would like to close with one important thought. Usage based billing is not about restricting developers, it's about enabling AI adoption responsibly at enterprise scale. The organization that succeed in the AI era will not simply use AI more. They will govern it better, optimize it better, and integrate it into engineering culture more effectively. Thank you, everyone. Happy to take questions.